Good evening, everyone, and welcome to this month's AHDB cereals and oilseeds monthly webinar. This month we'll be focusing on cereal disease management, and we'll be looking at how we can prevent, detect and control. As with everything, we've got some housekeeping to start. So firstly, you're all muted. We can't see or hear you, but you have got a questions box where you can send in any technical issues or get in touch if you'd like any questions answering. We're due to finish about 8:15, so we'll do our best to keep to time. And if you haven't already completed your basis and Noroso details on registration, if you send them in that questions chat box, we can get you added to the relevant registers. This webinar is being recorded, so if you missed something or you want to go back and watch it again, or you have to leave partway through, please don't feel like you're going to miss out, because you'll be sent a recording of the webinar, and equally all of our webinar recordings are available on our website. As always, cheeky Twitter plug, if you want to see what we're up to in the cereals team, you can find us on Twitter and you can follow the hashtag #MonitorFarm. So tonight's agenda, I'll quickly go through a welcome, and then we've got Tim, who's going to talk about cereal disease prevention, Rosalind, who's going to talk about detection, and Patrick, who's going to cover off control. We've got a nice Q&A session at the end, and then we'll close and hopefully get everyone away for 8:15. So without further ado, I'm going to hand over to our first speaker, Tim, who's going to cover off cereal disease prevention.
Good evening, everybody. I'm Tim Parton. I'm the farm manager at Brewood Park Farm, which is in South Staffordshire. I try to farm as biologically as possible. And mine is very much a systems approach, so it all really starts with soil health. We farm 300 hectares. I grow as large a rotation as possible, because the more variety I can get above ground, the more variety I can get below ground in interacting with different fungi and microbes, and hopefully driving my soil to health, to create a healthy plant, to create healthy food. As I just said, it all starts with healthy soil in my mind. This is a cover crop of beans, rye and veg, and the bean plant just shows a healthy soil in my mind. I've got all that interaction with biology there. There's glomating glues around those roots, which is gluing it all together and holding those nutrients together. And it's just the start of the process in my mind in preventing disease in the way I farm now. I don't use insecticides. I've really reduced herbicides, and I'm trying very hard not to use fungicides at all now. And it all starts with the soil, a healthy plant. In order to do this, I'm no-tilling. So I've started off strip tilling, and I eventually moved to no-till 6 years ago. And in order to do that, I had to adapt the drill that I'd chosen to be able to do what I wanted to do, because I wanted to put biology down next to the seed in order to create this healthy plant and start as I mean to go on. So as I said, it's a systems approach. It's not trying to treat a symptom later on in the program. Mine is a whole approach. It all starts with getting that biology down next to the seed, as I said, and I brew that up with my brewer. It works out very cheap, so I'm brewing up nitrogen fixing bacteria and phosphorus releasing bacteria, and I'm also putting trichoderma down there. Now, trichoderma is a very aggressive fungi which will eat any pathogens that are going to attack my plant. If there's any fusarium on the seed, it will eat that. It also releases phosphorus, so it's just giving me a real healthy plant from the start. And starting as I mean to go on, really. So I'm trying to get those biological interactions straight away from day one, and keeping that plant healthy and keeping everything balanced as I move forward. The product as I use is BioPlus T. It's an AHDB product, and it's very cheap to brew up. It costs me, I've got it down to about £2.50 a hectare. But it's just starting from that health base. So I'm just to say, I know I'm repeating myself there, but it really is the systems approach, and it's starting from day one as I mean to go on. And by having that right bacteria and biology there, that fungi there, I'm keeping that plant healthy from day one. So I'd say I won't get an aphid attack because that plant is balanced, and I won't get a disease attack. Humic acid is a very good fungal food, so I put that down. I also use fulvic acid because that has got a CEC of 1100, so it's just attracting any available nutrition around it, hold it so that plant can use it. But it's the humic acid that I'm really putting down there for as the fungi food to feed that fungi, that I'm trying to get that interaction and get that symbiosis going between the mycorrhizal fungi and bacteria. So that interaction is going and the nutrition is released naturally to the plant from soil. And by having that healthy soil, again, I have that healthy plant. I try to work with nature rather than fighting against it. I find that now I'm working with nature, life is a whole lot easier rather than trying to swim up the river and always going against the current. I'm working with her, I'm working in harmony with nature, and it just makes life a whole lot more fun rather than trying to fight nature all the while by using chemicals. It's working really well for me, and I'm having fantastic results. But it is a systems approach. It's not just a quick fix approach. I also, at the start, I put diatomaceous earth down, and that's micronized diatomaceous earth. So that will go down next to the seed, and the plant will take that up and it will become monosilicic acid. So it's silicon actually going into the plant, and that is a real start of my defense against disease coming at the plant, because it'll make those cell walls, it'll give them an armor, and the plant's just strong. So I don't use growth regulators for the same reason, because that cell wall is strong and it's defending itself naturally against any pathogens coming into the crop. And I'll go again in the spring and spray another dose of monosilicic acid on, which will then go down to the roots and just reinforce that coming into the spring. So again, I'm always ready for that attack. It's just getting that plant ready and armored. That's just showing the difference in roots. The one on the left is just a seaweed-based product. The one in the middle was a molasses product, and the one on the outside is that humic feed, which is just showing the difference it's made. And I've just got that plant in a good position, so it's ready to get as many roots out as it can there, to find as much nutrition as it can and get itself established before winter sets in. And it's just building my armory, as I keep saying. It's just getting ready for that plant to give it the best start I can in life. That's my toolkit that I use to monitor the plants coming into the spring. So I monitor pH. I'm trying to keep the pH of the plant at 6.4. If it's below 6.4, then I'm likely to have a disease attack. So I need to act and get that plant balanced again. If it's above 6.4, then I'm in for a pest attack. So again, it's keeping that plant balanced. I'm also monitoring nitrogen as well at the same time. If I can keep that nitrogen at the right balance, I don't have that explosion of growth and making that cell wall weak. We also had strong nitrogen can be with that explosion of Beirut last year. It's a powerful thing, and it does exactly the same to the plant if it's not used in that correct formation. So it's just keeping the plant balanced and all the while level playing field. I monitor for calcium as well. Calcium carries all those nutrients around the plant, and it gives that cell wall strong. So I'm just monitoring for the amount of calcium going in there. And then I've got my refractometer, which I'm measuring the sugars in the plant. Last year I was getting the readings of 16, 17, and if you're up there, you're not going to get a disease attack or a pest attack, because that plant is balanced. The sugars and the proteins are going into amino acids, it's going to growth, and that plant is strong and it's all functioning as it should. And then the last one on the outside is my Redex monitor, so I'm starting to measure the amount of electrons within the plant, again just for plant health, just to make sure the oxidation's right within the plant, so I haven't got any problems with not having enough manganese or too much iron. It's just keeping that plant balanced. Everything I do is about keeping everything balanced and level, so I haven't got any reason for that plant to be attacked by any pathogens. That's a Sap test that I have done at the lab in Holland, and again, it's just part of the toolkit, just so I can see what's going on. It's not going to be 100% accurate. None of the testing that I do is, or anybody does is, but it's just put that parts of the jigsaw, so you can just start to build what's happening in that plant, and you start to see a pattern forming, so as I can start to get foliar nutrition onto that plant and keep that plant balanced if it's necessary. The one thing I've found with these dry springs is that biology doesn't work as well when you start to get dry soil, so that's when I need to step in and do foliar feeding. So I'm all the while using a foliar product to keep that plant balanced. I use a product called Flex, which will be 90% available to the plant, and with the fulvic acid that I mix with it, it's all going into the plant, and I can balance that plant out very quickly again just by monitoring what's going and keeping it on that level playing field, so it's not vulnerable. Attacks not going to happen because the plant is in perfect health. I also do Sap Tests, which again, it's tissue test. It's just working along the same line. It's just seeing what's going on in the plant. I think Sap is a new one for me that I started last year. So tissue testing is something that I've done for the last 6 years, and Sap is a new one. So it'll just be interesting to see what's going on. But it's all about keeping that plant balanced with nutrition, so there isn't any imbalances there. And I'm always trying to get my nitrogen down as much as can. So 6 years ago, I would have been at, say, 240 kilos per hectare. This year, I'll be growing crops at 120 kilos a hectare. Because the soil is fixing nitrogen itself, it's giving the plant, so I'm not needing to put as much on. And by doing that, I'm getting those high Brics readings because I'm not overloading the plant with the nitrogen and opening those cell walls up. It's just working in harmony with the plant and keeping that plant, say, balanced all the while, so it's not vulnerable. It's just like us, if we have loads and loads of sugar, we know we're going to have health problems, and plants are exactly the same thing. It's just keeping it balanced so you don't have that invasion. Mulder's chart is something I often refer to, and it's just showing the synergism and I can't say the word, antagonistic against each other. So it's just that guide just to show you what's going on within the plant to keep it balanced. It's all about keeping that plant balanced, because in my mind, the most limiting yield factor is that weakest nutrient. If we've got a deficiency in boron, for instance, we're not going to get the maximum amount of yield out that plant, and we're not going to get the exudates going down to feed the fungi in the soil, because boron acts as the trapdoor to let the sugars go back into the roots to go out as exudates, which is all part of the process of keeping the healthy soil, to keep a healthy plant, to produce healthy food, to hopefully make us healthy people. That is what my goal always is. But I often refer to Mulder's chart just to see what's going on and see if that antagonistic problem is happening, if I've got an element getting too high or too low. It's just referring back to it. Pulsar is a product that I get from Ava Fertilizer, but it's just my starting product really of what we've built up, of what I'm normally short of, and we'll add things or delete things, but it's just my starting product of doing that foliar feed to keep that plant back in balance. And because it's so available, it's so effective. I haven't found another product to beat it. It's not that I favour Ava, it's just the fact I love Flex Fertilizer. It's from Denmark, but because they're so tight on their nitrogen use, they've developed this product, which is just a fantastic foliar feed. This is a crop of wheat from 2 years ago, because if I do start to get it wrong and disease comes in, I brew up bacteria again. I brew up Bacillus subtilis, and I brew up Amyl liquefacium. The Amyl liquefacium is like the big cousin of the subtilis. So if the Bacillus subtilis hasn't done the job, the Amyl liquefacium does, and that just shows the difference in brown rust there with treated and untreated. And if I hadn't have treated, I would have had a massive yield deficit. That crop, well, all the crops that year, they came anywhere between 9.5 to 10.5 tons a hectare. So I was more than happy with that, and my total disease control with all the nutrition and everything was coming in at about £50 a hectare. So again, I was more than happy with that moving forward. This is a field of barley, a trial from a couple of years ago, and I grew that on 40 hectares of soil applied N. The rest was done with nitrogen fixing bacteria, no fungicides at all. The side on the left is the biology side, the side on the right was the farm practice at that time. and the farmer side on the left yielded slightly better according to the combine yield monitor, and obviously it cost me a lot less. But it's also that factor of keeping that healthy soil and moving the whole thing forward. That's just a leaf tissue test just to show the difference between those two crops, and you can see the conventional crop on the left there was high in nitrogen, which I suppose I would have expected. The plant will keep itself balanced if you're not overloading it with synthetic nitrogen. So it's just keeping it, it's just to show that I'd still got high nitrogen within that plant, and the fungicides were needed for that side, but for the biological side they weren't, because I'd kept it balanced. This is some of my wheat coming into the spring. I know yellow rust has been quite bad on crops around the country, and my crops are clean. So it just makes me a content farmer that I've got it right so far. Fingers crossed for the rest of the season, but it's you know, it's an ongoing thing, and management is high in the way I farm, but obviously, you know, the benefits are there. That was my oilseed rape last year with no insecticides or fungicides, and it was averaging 4.2 tons to the hectare, which just shows to show it can be done. That's I just dropped that in there just to show that. And this is a crop of wheat from 2 years ago again, no fungicides at all. The right hand side was down to 100 kilos of nitrogen, and the left hand side was 180 kilos of N, and it's just proving to me that I could drop my nitrogens lower. And so this year I will be down to 120 across the farm, which again will keep that plant balanced. And that's me done. Hope I haven't run over time.
Brilliant, Tim. We will come back to questions at the end, so do keep on sending them in. But we have had one asking, what sort of varieties are you growing?
I try to do blends because I'm trying to get the natural resistance of each wheat. So the wheats I'm growing this year are Trinity and Crusoe, because they've both got really good resistance to yellow rust. So it's all just part of the package together.
Brilliant. Thanks for that. And we'll look forward to the question and answer session at the end. But that brings me to our next step in cereal disease management. So we've looked at prevention. We're now going to look at detection, and I've got Rosalind Martin from Bayer here, who's going to talk to us about the rapid disease detection work they're doing over there. So over to you.
Yeah, thanks, Michelle. Great. So yeah, as Michelle said, I'm going to give a quick run through of the Bayer's rapid disease detection, which effectively is a new technology that we're developing to help better inform and justify fungicide decisions. So to kick off, I'm going to go back to basics. Just a very simple diagram here. Imagine this green blob is a cross section of this plant leaf. So when a disease infects a plant, first the fungal spore will land on the leaf, and then the next thing that would happen is that fungal hyphae grow inside that leaf. Then you'll get more fungal hyphae inside that leaf, and then eventually you'll see visible symptoms on the outside of the leaf. And the case of Septoria, that latent period where you don't see any visible disease, lasts about 18 to 21 days. And in the case of yellow rust, it's a bit shorter, more like 10 to 14 days. So it's quite easy to look at a crop, think it looks clean, but there may well actually be disease inside that leaf in this hidden latent phase. So this makes it complicated when managing disease and choosing fungicides, because first of all, fungicides are only effective in that early phase of the latent period, and certainly once the disease is visible and in that later period, then your fungicides won't be effective. And also during the point where they are effective, different products and rates will be relevant depending on the scenario. So earlier on, before the disease has arrived in the crop, or in the early phase when the spore's just there, then you'll be in a more protectant phase, and then later on you're more curative, so it'll be more appropriate to use products like azoles or SDHIs. So if we, I assume most of you will be, the next fungicide time that you'll be thinking about will be your T1 decision. So clearly the main leaf that we're targeting at that timing is leaf 3. And some of the factors that you'll be considering might include drilling dates. So clearly the earlier drilled crops tend to have higher levels of disease, particularly Septoria. Variety and genetics, clearly they play a big role in disease levels in the crop. So crops like Ixtays tend to have less disease, so there's higher resistant ratings on Septoria. You've also got winter weather to consider. So, I mean, this winter we've had a relatively normal temperatures, but pretty wet conditions, particularly in the east, so that will have accelerated disease to some extent. And then by the time we get to T1, we'll also be able to bring in factors like spring rainfall, which will encourage disease to smash up through the leaf layers, particularly in the case of Septoria. And also, we can, at this timing, do a visual inspection of our crops and look at the lower levels where you may well see some disease, particularly on those older leaves. But the challenging thing is that we can't actually see if there's disease inside the leaf layer that you're targeting, which may well be in the latent phase, and therefore it makes it harder to make a really informed decision. So that's where rapid disease detection comes in. So just to explain a little bit how it works, so Bayer have been using this type of technology all the way back since 2014, and in the last 2 years we've been able to speed up the laboratory process so that results can come back within 24 hours. So it's very simple. You simply select the leaf layer. So in this example I've just been talking about, at T1, the most relevant leaf layer would be leaf 3, the leaf that you'd be targeting. So you'd select a number of leaves from your crop, put them in an envelope and send them to the laboratory. In this case, at the moment, we're working with NIAB to do that testing. And they would carry out a qPCR reaction, which very simply quantifies the amount of DNA of the particular diseases that you're interested in that leaf layer. And we're now able to test for both yellow rust and Septoria in our tests at the same time. So I think it's important to note that whilst this is really interesting technology, it's still really important to still consider all of those factors that you're already thinking about in terms of your crop. And these are just a few examples, but some other ones might be more specific to your farm, whether you're maybe in a coastal region or on higher ground, lower ground, what the forecast is. There's still a lot of factors that need to be incorporated into your decision. But the way I see rapid disease detection is another layer of information to help inform and justify that fungicide decision. So just to share a little bit of an insight in interpreting your results. So the results that we're getting through at the moment, we are effectively giving you a number, would give you a number on this scale. And in terms of how you then understand what that number means for your fungicide decision, to be honest, we're still working that out ourselves. But the one thing we can be certain of is the difference between a negative result and a positive result. So if you have a 0 result, then you can be confident that you're in a protectant scenario, and therefore, multi-site protecting that chemistry would be more appropriate. Whereas if you have a positive result, then you know that you have got disease inside that leaf layer that you tested. So as I say, in a protectant scenario, that might mean it's more relevant to include a multi-site. Or in a curative scenario, you then know that you need to be selecting slightly more curative chemistry. And if you've got particularly high levels, then you might consider increasing the fungicide rate. But as I say, it's still early days for us in understanding what different disease levels mean, and that's all part of the project that we're doing this year. And actually, across Europe, we have over 80,000 leaf tests planned, which will all build together into helping us understand what this really means for disease levels and therefore fungicide decisions. So I thought I'd share a little case study from some of the testing that we're doing this year. So as I say, we've been doing this for 2 years now, started in 2020 with the rapid disease detection and worked with a group of about 50 growers to start trialing the technology. And this year we're working with a number of growers, including Mark Wood, based in Herefordshire. I'm not sure if he's on the call, but if you are, hi. And so, yeah, in the case of Mark, he's actually been sampling monthly since January and February, and then weekly all the way through March. And I thought I'd share just a little case study of his latest results. So Mark's been sampling these 2 fields. The one on the left was drilled on the 14th of September, so I've coloured that red to kind of reflect relatively early drilling date, therefore probably with high levels of disease, particularly Septoria. And then he drilled this crop in this field on the 26th of September, so still relatively early. And in each field he has drilled 2 different varieties. So on the 14th of September drilled field, he's put Wolverine in, and that has a Septoria rating of 5.3 and a yellow rust rating of 5, so both relatively low. So in your mind you'd be thinking, right, okay, this is probably a relatively high risk field in terms of disease pressure. On this field he's drilled crop of KWF 6 days, so much stronger resistance ratings there, so Septoria of 8.0 and yellow rust of 8. So what Mark's done is he has been sampling all this since January, but his latest result, he sampled the crop on the 22nd of March, and they went to the laboratory and he got this 24-hour turnaround result. And yeah, I'll be able to show you his results. So the Septoria results on the crop of Wolverine, as I said, represented on this scale. So interesting to see he did have a positive result in his Wolverine on that newest leaf layer, one that he just tested the newest leaf layer. So that had a relatively low level. And then you looking across to the X days, that also actually had a positive result, although relatively similar to Wolverine, but probably not surprising, slightly lower than the Wolverine. And in the case of yellow rust, in fact, both of those leaves that tested across leaf samples from both fields both had no yellow rust present. So Mark was able to use this information as well as all the other factors that he would have been considering about his field and incorporate that to help him inform and justify his T0 fungicide decision. So as I say, we've got big plans in terms of expanding the leaf testing, and last year, as I said, we worked with 50 growers, but this year we'd really like to work with more growers. So if you're interested in taking part and want to try testing the disease levels on your own farm, then we have a link on our website where you'll be able to register to take part. I think there'll be a link popped in the chat, or you can simply search Bayer Rapid Disease Detection on Google or online, and it should be the first thing that pops up. And when you register, you'll basically be asked two questions. One, which is, when do you want to sample? So obviously, probably encourage you to sample around the time that you expect to be applying your fungicide to help inform that specific decision. And you'll also be asked what comparison you'd like to do. And this is all part of us trying to understand how it might be useful to you to use this test going forward. So we'd really encourage you to think how this is going to be useful to you. In the case of Mark, he's really interested in different varieties, but some other factors might be interesting to you. And I've actually, this is a little graph showing what farmers tested last year that we offered the test to. And you can see the most popular comparison was actually comparing different varieties, and then followed by drilling date. But there were some other more wacky and interesting ideas, for example, coastal versus inland crops, or spring wheat versus winter wheat, irrigated versus unirrigated. So whatever takes your fancy, it'd be really interesting to have go and take part in using technology. So as I said, we're expanding the testing this year, and one of the projects that we're working on is, I called it the National Snapshot project, and the idea of this is to start to build a picture of the national disease levels field by field across the country. It's quite easy to look on Twitter and suddenly think there's a yellow rust epidemic out there, but what are the actual disease levels in real commercial fields? And by able to take samples from lots of different fields, we're able to start to build up a real view of the actual levels across the country, field by field. So to share with you a little flavour of the results, the way this has worked is each of these regions is a region represented by a local Bayer technical manager, and I've asked them to partner with a local farmer and choose one field with a relatively higher Septoria risk and one with a lower Septoria risk. And you can see here, these are all the results. So these results were actually taken in the last week of March, and they were testing the newest leaf layer. So the sort of top leaf of the main stem of each plant. And it's probably no surprise to see that most of the results are 0, which probably reflects what we'd expect at this sort of timing in this season. It's kind of reassuring to see that maybe even though we had some wet weather over the winter, it hasn't really accelerated disease massively, and it certainly hasn't transmitted up to these higher leaf layers. So in most of these scenarios, if the farmer was considering a T0, then he could be confident that he's in a protectant scenario, he or she's in a protectant scenario, and therefore either choose to maybe not include a T0 in the programme, or choose a sort of a fairly simple maybe multi-site or azole type option at T0. And there are a few positive results in here which are interesting to look at. So our site here up in Perthshire in Scotland, you can see that we compared a crop of Sundance and a crop of Skyscraper. It's probably no surprise that my colleague Grant and the local farmer there found that there was disease present in the weaker varieties. Sundance with a rating of 5.1 for Septoria, whereas the stronger variety with a rating of 7.9 has no disease present. These results here, the one we've just talked through from Mark in Herefordshire, which is probably no surprise, well known to be a hotspot for disease there. But interesting to see at the site in Cornwall, which you'd maybe expect to see more disease, whilst they're relatively resistant varieties there is no disease in that newest leaf layer. There may well be disease lower down the crop, but as I say, this is the newest leaf layer. The last site, just of interest, probably no surprises there, and we are starting to see positive results coming across from crops being tested in Ireland, where clearly the conditions are there more conducive to Septoria. So yeah, that's the sort of national snapshot of Septoria, and then this slide here looks at the yellow rust results. Now, as I said, you might think that there's a yellow rust epidemic happening right now if you only look at Twitter, but from this testing and the results from these fields that we're looking at, we've not found any yellow rust present in the newest leaf layer of these crops. Now, to be fair, we have seen yellow rust about in various trial sites, and particularly on weaker varieties, but at this moment in time, and I guess thinking about the T0 and looking forward to the T1 decision, it doesn't seem like there's, on these particular crops, a real concern about yellow rust. And if anything, you can be confident to choose a more protectant type program when you're considering your next fungicide applications on yellow rust. So just to wrap up, in summary, as I said, they've been working on this project for 7 years and building up a really big data set now that we can start to compare results year on year. That has really exciting potential, this technology, to unlock this new information to be able to inform and justify fungicide use. And I see this really important going forwards. It's important that we really justify what we're doing, especially with a much bigger focus on sustainability and scrutiny there is around the world of pesticides. As I say, we're also really keen to work with growers and agronomists to develop this technology into a useful tool. And just as a reminder, if you would like to take part this year, then yeah, please have a look at our website, and yeah, you can register your interest to take part. And finally, what the future holds for this technology is very exciting. So in terms of other diseases, we have already started a project looking at eye spot in wheat, and we're able to actually type between different eye spots. That's not wide scale available just yet. But we've also started looking at the possibility to be able to use this technology in barley to detect the key diseases in barley. So yeah, looking forward to this in the future. So that's it from me. Thank you.
That's brilliant, Rosalind. And you'll be sticking around for the questions at the end as well. And as you said, that link has gone out in the chat. So if anyone would like to follow that link, please do. And do continue to send in your questions. So we've looked at how we can prevent and then how we can detect cereal diseases. So that brings us on to Patrick, our final speaker, who is going to look at the last stage of an IPM programme, how we can control cereal diseases. So over to you.
Hi, I don't know if you can see that. Have we got that on board? I'm just seeing my face, which is not a pretty sight. So
we sure can.
Right, let's make sure I can get that out of the way. And there we go. Right, I'm at the part of the program where prevention and detection have come to the conclusion that we're going to have to do an element of control. And I'm not moving forward. Sorry. Oh, hold on. We're moving forward now. And basically, I look at the first part of where we're going is what is control? And in essence, it's the power to influence the behavior or the course of events in terms of where we are. And that from us is the agronomic intervention to ensure that we retain green leaf as long as possible. And we've already heard that in the prevention from our first talk, and then how important variety is in the second talk. And I'm coming in really from the aspect of using what we would call conventional chemistry to go that way. And over the last 15 years, we've basically developed a program that is 4 sprays for wheat and increasingly 3 in winter barley. But the problem we've got now is that we're starting to lose active ingredients that are no longer being renewed under the Sustainable Use Initiative or under water or other aspects of environmental impact. So what we evolved was a farming system purely based on a recommended list where yield increase was the primary driver. So there were varieties included which had traits that were important to us, but it had to be accepted that the list, the recommended list, the AHDB recommended list was geared, slanted towards the impact of yield. And with yield, we tended to be losing some of the natural inherent plant defense systems that were available there. So broken down, and you'll see on the right hand side there, I've put a range of prices that could be there. So if you're using what we would call a conventional farming system, but you're using what is readily available in IPM, so that's varietal choice, it's date of drilling, it's the application of fertilizer in wheat. You've got a range of fungicide costs that are in that system. So one could say that if I'd got in a conventional agrochemical system, I'd got my IPM right by the choice of variety, my drilling dates, and the use of artificial fertilizers. I'm sort of on the left-hand side of the price premium. If I've chosen another method of growing, or I'm in the wrong area but the wrong variety, I'm going to look at a cost of a program that's more to the right-hand side. So I've tried to give you an example there. Somebody in Cornwall decides to grow the variety Barrel, whereas somebody on the Yorkshire Wold grows X-Tays. So you've got a potential cost differential that's there, that's over the element of control. And if we're looking at wheat as well, for most of us that are involved in arable and wheat production in the north of England, we will be drilling early because our climatical window is very limited. So by the time you're in Scotland and you're after the first week in October, the opportunity to get wheat in is very, very limited. But to the south, around Cambridgeshire and that area, you've got blackgrass issues, so the ability to drill later is there. And later drill brings different issues into disease control than, say, early drilled. And one of the things you look at in this very congested slide really is the length of time between one growth stage and another. So when we've got later drilled crops, the growth stage is concertina quite a bit, but we're never far away from the same point in time when the ears are emerging, because daylight driven as well is a key factor of it. So it sounds daft to start about control, but basically understanding the growth stages and where we're at in the system is a critical part of where you are in a control program that's based on basically conventional chemistry. We've already seen that the disease cycles can vary quite a lot, can vary with weather. So interesting to see Rosalind's slide there on what they're picking up on the top leaf, but it's not a surprise in many ways because we've had about a fortnight of reasonably dry weather, very little rainfall. We've got cool temperatures now. So the development of disease coming forward is going to be slow, and moving up onto the leaves without that leaf wetness is also going to be slow. So we're starting off from a strong position this year where we are, but when conditions do come back in favor, some of these varieties will develop disease very, very quickly, and how we manage to control that is really important. I've got this out here to show you when you're choosing your products and your actives for control going forward. You've got to bear in mind the efficacy of the product you're using. So Rosalind's talked about protection, and we're looking at a protection situation where we're starting the season. But remember, the older triazoles that are in our program, their efficacy is falling. So although they retain some good activities, particularly against the rusts, when you look at them in a Septoria position, you might feel now that I'm really dry, I'm only going to put on a triazole as part of my program on a variety that's maybe a skyfall type thing with a 6. But remember, within that, the efficacy of the product, the ability for it to retain its protectant activity is diminished quite considerably from what it did when these products first came out. So if you're using a form of SDHI chemistry, what we're going to see is that there's increased efficacy there. And the new chemistry that's coming towards us as well will again have an increased efficacy. So what you get with increased efficacy, as we see in many of these new products, is an increased ability to operate in the latent period. They're not a cure-all, but they do give you an opportunity of ensuring that we cover a wider period of time where we can claw back some level of infection that comes in. And this will tie in well with Rosalind's work. It'll also be very useful where we're using regenerative types of agriculture to monitor disease that may have come in when extremes of weather into play and the crop is stressed by factors that you can't control. So the two things, new improved chemistry, along with that ability to detect, will in the future going forward matter greatly. If we look at where we are today, and you look at the range, I put a list of products here, but I'm not saying these are the onlys or which ones I would choose, but it does show you, for instance, with a variety like X-Tase, where we've got a good natural resistance to Septoria, but we can detect yellow rust in some areas of the country. In X-Tase, you have the opportunity to produce a very cost-effective program that's in there. When you're going on to varieties like Adexar in Costello, if I'm growing Costello in Cornwall, it is a different animal to growing Costello in North Yorkshire. But nevertheless, you have flexibility to utilize chemistry. So when we look at whether we're going to use a multi-site, that's the Folpet, so sort of an Arizona type product, or a Mancozeb or a sulfur in the program as a multi-site, the weaker the chemistry is, the more a multi-site will add to the benefit of that product. Also add to that, the weaker the natural resistance is, the more important a multi-site is that comes in to assist that. So it's a balancing act that's going there when you're controlling using a choice of chemistry to fit the variety you've got and where you've gone. So by the time we're moving into T2, again, the choices are there. If we're looking at a product like Elatus, where we've got very good rust protection, then you might consider that on, as Tim was saying, with the Trinity mixed with the Crusoe, or if you're growing Crusoe only, you may consider that as an important aspect to it that's there. Skyfall's another with a yellow rust weakness, where it's actually quite good on Septoria. So you match your product accordingly that's there. And in the new chemistry, in the Revistar and in the recent release of the Corteva products, the Inatrek based products as well, you've got very active Septoria products. So in the Hereford area, where we picked up disease there, in Southern Ireland, where we picked up disease already there in a time where we've got very low risks that are there, these products are going to be very important in that part of the equation. They do have weaknesses, but it's the Septoria activity is exceedingly good. By the time we get to T3, it's really determined by what your end market is, how important Fusarium is, who is the purchaser of your end products. So we have options for control that are there. We have a price range that's there, but price isn't the dictum, it's disease control. And you have to marry that in with not only the weather you have now, but the weather we're likely to get going forward. So I've put down an example of a program here that might be applicable to a variety in the north of England. It's not something you can stick with per se, and I know growers have to plan forward, but there is flexibility within there in the rates of products you use and the timings you go. So for instance, if we had a 2012 where the rainfall just never stopped, you may not have the opportunity to spray exactly on time. So the rates of product can slide up or down as the pressure mounts that's within them. But where we are compared to where we are with, in 2012 is we've got a lot more varieties that are giving much more robust Septoria levels of resistance. If we move on to barley, barley is different. So if you remember where we were with the wheat and where the contribution of yield comes from in wheat, there's a very strong emphasis on flag leaf in wheat. Has been a major contributor to yield. Yes, we do leaf 2 is important, the E is important, and leaf 3 is important, but flag leaf by far weighs the greater part of it. In winter barley, the contribution of the various parts of the plant to yield are much broader across a theme, but you will see that this emphasis on earlier control in barley is more important. And when you match that with the capacity of the crop to produce a yield, by the time we're in the first week in April, that crop will have the theoretical maximum yield. So it isn't a surprising that barley timings are stronger early with a more expensive combination of products that's going in. And if you look down there, what's available in terms of products, there's a cross section here that's there, and it's the various actives that are in there. You can see that we have a reasonably good range of products. We have reasonably good efficacy. I am concerned as we move forward that we have issues with net blotch, which we may struggle with as we move forward. And those of you who are old enough like me to remember crops like Sonia and Igri and Marisotta, net blotch can be a really significant problem. And Ramularia now, with the loss of chlorthalonil, is once again rearing its head as a potentially devastating disease. They saw very little of it last year, but we're fairly confident that it's endemic in our seed lots now. So if the conditions are right, we could end up with a problem. So I've got here a list again of options that are there. That Siltrus, Fandangos, Elatices. You judge the active where you are, and we think of where we're going. But what I would say, this first timing, which will be imminent, many people now will have already applied their first fungicide to winter barley, but you're looking down that range of products that are there, and hey, you pay your money, it takes your choice. But they are still very effective in barley. We get good levels of control currently. But what I would say to you, this is an area of change, particularly so in barley, and no more so with Ramularia currently. So often we ignore Ramularia, and one of the points is you don't see it in the early part of the crop. Where we see it is when the flag leaf is emerging and the ears coming out and there's some element of stress. You'll often find it on wood sides when there's tree pollination coming out on the leaf. That sort of stress around that tends to cause it to go emerge in the leaf and can be quite a yield robber in those situations. Then we move on to the final timing, and I'd encourage you in this final timing to make sure that we get the awns covered. If you remember back to the contribution to yield, you'll see that the awns are very important in barley. And in covering that awn is also very important. Do bear in mind if you're going for a malting sample, and there are restrictions on the later timing that they're there. With spring barley, I see the difference is a lot simpler. You've got a much tighter, shorter growing period, and fungicide usage in spring barley is a lot more difficult to get an economic justification all of the time. And it is a crop you monitor regularly and look at rates of product that are much, much lower than you would anticipate using in winter barley. That in brief gives you a summary of where I see the disease levels of control, and I hope I haven't gone on too much and too far. I shall hand back to Michelle.
Brilliant. I hope that was a great overview of cereal disease control, and we're perfectly on time. So I'm going to ask all of the speakers to join us and we'll have a look at some of the questions. So starting with Tim, as you set us off so well, when in the day do you do your Brics tests, and on what leaf and what numbers would you want to see?
I always do my Brics tests late afternoon. Any time after 12 o'clock is probably okay, but I always like that 4 o'clock sort of time. And I'll do the main leaf, and I'm looking for anything 15 and above.
Brilliant. And linked with that as well, we've got quite a lot of questions in for you. So there's a lot of management involved with your system, which you acknowledge, and getting the healthy soil bit is the easy bit potentially. What's the next step to understanding how to achieve the level playing field of plant health? Is it a whole new skill set? Where would you start next after you've got your soil right? What's the next step really? It's all
a whole new skill set. Starting at the beginning is getting that soil healthy, obviously, which is not easy. Soil can go backwards as fast as you've moved it forward. So it's always an ongoing process. It's a passion of mine. I read an awful lot of books. I'm probably well over 100, probably 120 now, but it's just ongoing passion. And it's something that's always evolving, it's moving forward. And what I did last year, I'm doing something different this year because we're evolving so fast.
Brilliant.
I don't know whether that answers the question, but that's...
I think that's the big thing, is it is changing all of the time, and it's about keeping up and just doing what you can. And I don't think everything's achievable at the same time, but doing your best. You've
just got to do little steps to get on the path that I'm on, and it's no good trying to think that you can just come in and go from A to Z without doing the work. You have to earn the right to get to where I am. It's not just a gift to you. You've got to earn the right to get there.
Brilliant. I'm going to use you to jump across to Rosie. So, Tim, are you interested in trying the rapid disease detection? And would that be something that you go forwards with to understand when disease does come in?
It's not something that I'd use, no. But I don't take anything away from it. I can see that it'll be a real handy tool, but it's just not something that I'll be using, no.
Brilliant. And if you were to use it then, Rosie, when in the season should we start thinking about using the rapid disease detection monitor, and how many times through the season?
Yeah, good question. So to be honest, there's no hard and fast rules. Like I said, with some farmers we've partnered with this year, we're sampling all the way from January through to June, and weekly during the key part of the season. But clearly it's an onerous thing, walking to the field, taking leaf samples and sending off to the laboratory. So if you wanted to just focus in on how it's going to be most useful and relevant to you, then I would suggest sampling in the days before you plan to do your next fungicide application, and select the leaf layer that you think will be most relevant to that. So for example, at T1, then leaf 3 will be the most relevant, and then at T2, leaf 1 or 2 might be more relevant, and then send them a few days before, and they can help inform that latest decision. But yeah, if you want to test every day or every week, then it's up to you. There's no hard and fast rules.
Brilliant. And that will relate to, as weather changes, it'd be about getting an up-to-date picture as the weather changes through the season as well, I suppose.
Yeah, exactly. And I think that's important to note. The result that you get is telling you the level of disease in that specific leaf layer on that specific day. And the weather, we know from testing where we've been tracking disease levels, if there's a huge amount of rain in the week after the day that you test, then we know that that will affect the disease levels. So that's why it always has to form part of the bigger picture of all the other factors known to you, what your local weather's been, what your forecast is going to be, and it all has to feed into that whole disease management decision.
Brilliant. And then coming back to thinking about disease management and linking all three of you together, which is a brilliant question. As an independent agronomist, Patrick, what's your opinion on the Brics test and the bacteria for using these inputs? Have you seen any work with it? What are your thoughts?
I think there are a couple of things that are very key to what Tim's does, and the first thing is rotation. You know, I think it's the mixed flora and fauna within the rotation that is contributing a considerable amount to what Tim's success is. And you know, if I could wish something off from elms to be there, is that a wider rotation is part of the requirement, because you know, it's that mixture of rooting systems that are out there that are helping you know, produce the mix of biodiversity that we need. And you know, we've grown away, and don't get me wrong, wheat rape or wheat rape has served a lot of growers very, very well, but unfortunately, whether they like it or not, the times are changing, and we have to address this. Tim's system isn't going to be for everybody by a long chalk. And you know, if you're in Aberdeenshire or you're in Northumberland or something, the flexibility you've got in doing some of the things Tim done isn't there. So, but it doesn't mean to say you can't adopt some of the techniques that are used and measure the outcomes of that. That's the problem, as Tim alluded to. People take it on board and expect instant results in Cardigan Bay through to Perth, and it is your farm, your system, and you adopt it and use it, and as what you know works. And that's the problem we have in today's Facebook social media society, as Rosalind alluded to. You would have thought the country was plastered in yellow rust, and there's You know, actually, the weather pattern from the beginning of March to the end of March changed so much that the yellow rust, the inoculum's still out there, but it's not visible in many cases. So it's a long-winded answer, and you know what Tim's doing is working for him, but what Tim's principles are would work for a lot more people. Not necessarily exactly how he's done it, but it would work.
Brilliant. And linked to all of that and how we are changing as an industry, a question, as an industry, are we guilty of speeding up the decline of efficacy of products by reducing rates away from label rates? The first thing we seem to do is reduce product rates as low as we dare in this, as this is accelerating breakdown. And it kind of links in with the work that you're doing as well, Rosie. So I'll let both of you have a chat about where late rates could be amended and what the effect of that is. So Patrick, you first.
Yeah. You see the manufacturer's rate, you divide it by 4 and put it on. Yeah, I know. Joking aside, this has been a long held. You use the lowest rate where the product will retain its efficacy, and then it will last longer. Now, what that figure is debatable, should we say? But we've got the same issue coming up with oilseed rape and clubroot. You know, if you've got clubroot on the farm, do you just immediately move over to varieties that are resistant to clubroot? That is the situation in Canada. They just go straight over. But you're exposing the clubroot resistance to an immense level of pressure. So the question is, with the new chemistry, the answer really should be, if you've got 2 new streams of chemistry, you put them on at lower rates together and get the best efficacy and elongate their effectiveness for a longer time. I don't want to pay the bill for that, but it is, you know, that's the way I view it. You use a low rate where you retain efficacy, and the principle behind that being that, yes, some of the disease might skip through, but if you use the highest rate, the one that does skip through is resistant. And that argument, I'll leave that to Rosalind and the technical boffins to come back to me and say you're wrong, which will happen. I'm pretty sure that'll be the case, but over to you, Rosalind.
Yeah, well, to kick off with resistance. So the best resistance management strategy would be to apply no fungicides at all, but clearly you've got to balance that with efficacy and getting return on investment for your crop. We clearly know that fungicides give value to and increase crop potential. So yeah, there's all sorts of principles in terms of mixing mode of action, and rates is really key. And obviously there's different rules depending on different modes of action and actives that you're using. So yeah, clearly I'd always encourage you to use appropriate rates, and I think that's where the careful balance is. It's using the right rate, not too low and not too high, and factoring that all in a wider image of how to manage resistance.
Brilliant. And following on from that, is the rapid disease detection tool a good first step for a I'm going to put this in inverted commas, normal grower who doesn't have the time to go out every day and tissue sample?
I would say, to be honest, I think the rapid disease detection is probably more suited to someone that's really keen and interested in their disease level. So probably it's not every farmer is going to be desperate to go out there and sample leaves. I would definitely not suggest it's something that you do every day. I mean, probably there's 2 key fungicide times in my mind, T1 and T2, where the real value is. So if you could go twice out in a season, that would probably be enough or sensible, or even just once with T2 timing, or work with your agronomist to do it. So yeah, clearly I've explained all the benefits of it. It helps inform your fungicide decision. So it might mean that you want to spray a higher or lower rate, or include a multi-site or not. So getting better value from your fungicide by being better informed about it. So if that floats your boat, then feel free to use it. And if it doesn't, then either get your agronomist to do it, or you don't have to.
Brilliant. And then a couple of things. So back to Tim. We've had some questions about how you regulate your pH to optimize the plant growth.
It's all about keeping the plant balanced. But if, for instance, I'd got an alkaline pH, I'd probably put some sulphur on, but that would depend on what my sulphur rates were. But I just bring it back as best I can. Normally, I'm not in that situation because I've already got it balanced before we get there. But there's certainly products I can put on to move it either way.
And what would you say are your normal nitrogen timings and rates and number of passes? How often would you go on with nitrogen?
Nitrogen, I try to split it more than what I did. So probably when I was still up to 150, 160, I would have gone at four intervals, because it's just not having that big, massive drop on the soil that the plant's just going to suck up. So I try to keep it balanced. And by doing that, I'd also do a foliar spray to keep that plant balanced after of all the other nutrients to keep it balanced. Now I'm dropping down to 100. I still probably do three splits and then go in with foliar N as well, just to keep the balance, so I know I've got enough nitrogen there, because I can't do without it, but I don't want too much there.
Brilliant. And when you did move from your traditional system towards this regenerative system, mint hill type things, how long do you think it took to see the results? How long until you got it to the level you're at?
Oh, to get it to the level I'm at, it took till today, because it's constantly improving, and it will keep improving. It's not, and it can easily go back if I balls it up, which, it can happen. But at the end of the day, we're still in business, so sometimes you have to do things you don't want to do to save the crop, and soils can go backwards, as we've seen with the weather. To see the real sort of differences on my land, it was probably 3 years where you started to notice worm numbers going up and the soil starting to repair and come alive again. I think if I was on clay soils, it's probably more like 5 years before you really start to see the benefits. But that all depends on what state the soil's in before you even start, because if you've got an anaerobic soil, you can't just jump in and do what I do. You can't just magically expect it to change overnight. And if it's been used to loads of high inputs, it's a drug addict, and you've got to wean that soil off, and you've got to do it gradually, just like you would any drug addict. It's a long, ongoing process.
Brilliant. And speaking about getting a healthy soil, what are the metrics that you look for soil health?
Oh gosh, what would I look for? When I walk into a field, I measure with my feet, because if you've got a healthy soil, you can feel that springiness in your feet. People like controlled traffic, but when you've got a healthy soil, you don't need controlled traffic. You can drive anywhere you like on my soil, and it'll just spring back up as long as it's in the right conditions. So my feet are always my first measure. Visually will be the next. I'll look for worm casts to see what worms we've got. I'll get the spade out. Everybody should have a spade, and look at the texture, look at the colour of the soil. Ideally, you want that nice coffee colour, so you've got a lot of carbon going back in there. And then I'd use to smell the soil, smell that acetinomycetes to that nice healthy feel good factor, and you're starting to get a good soil. So you don't have to spend a lot to start and assess your soil and see what's going on.
Brilliant. Thinking about control then, so Patrick, you touched on net blotch. Do you know if any work's been done with Bugle or Proline instead of Silkra?
Basically we're relying very heavily on the Profile, so they're part of Bugle, and obviously our Proline as well. So it's really useful if you go back to the AHDB fungicide response curves and go back to about 2009 when we started first using Profile, and you'll see a very lovely sort of walking stick curve showing very good levels of control. If you go back to this year's, you see what would best be described as a gentle slope. So I think they're evident, but Profile is a key ingredient in barley and still will remain a key ingredient in barley. But the supporting acts are, we're not getting the level of certainly eradication we previously had. And, I think we will find going forward with our existing chemistry some issues arriving around net blotch.
That's great. And then we will do one last question. I've been avoiding this one because I didn't want to say it. Do you see any inadvertent pest control effects, Tim, from the diatomaceous earth?
Could you repeat that, sorry?
Do you see any inadvertent pest control effects from the diatomaceous earth?
No, because the diatomaceous earth that I use is micronized, so it's ground up to a powder. If you use just pure diatomaceous earth, then yes, it would have an effect on soil biology, and it would quite easily be detrimental to soil biology. But the stuff I used is micronized, so it's already smashed up. So to a bacteria, it would still look like a tower block, but they'd just go around it. So it doesn't have that effect, but it's got to be micronized. It's not just pure.
Great. And last ones for Rosie. What's the sort of cost of the PCR test, and is it affected at all by race changes?
Good question. So if you register on the website this year and take part, then it's free. As I say, we're still developing it and still really trying to understand how disease levels detected translates into fungicide decisions. So at this stage, it's free. So yeah, I know farmers like free things, so fill your boots at the moment. And is it detected but affected by race changes? So how the qPCR process works is it effectively selects a small section of DNA that is known to us in Septoria or yellow rust of the known pathogen, and it effectively sticks to a section of that and then clones it lots of times, which is how qPCR works basically. So long as there hasn't been a base change in the genetic pairs in that race change on the bit that we're testing, which is massively unlikely, then it is able to detect all Septoria no matter what race it is. In terms of going forward and be able to detect between different races, we can create what they call primers that stick onto it to the parts that we know are different in those different races effectively. But that's a little way off, and we'll only be able to do that for known races as opposed to new races that pop up. So yeah, definite potential in the future.
Brilliant. And last question for Patrick. If there is one piece of cereal disease management, fungicide management advice that you could give to growers, what would it be?
One piece was, that's put me on the spot, doesn't it? Really, I was done. Pick the right variety. The minute you've picked your variety, you've written under conventional or current agriculture, you've written the check that you're going to spend on fungicides. So pick the right variety.
Brilliant. That's a great recap. And they're all the stages for IPM, really, aren't they? And that's what it's all about. Fab. So without further ado, I will just bring us to a close. We have focused on fungicides this April, and available from this Friday is our Fungicide Challenge podcast. You can sign up for it at ahdb.org.uk/podcast. Also, we've got our IPM hub with various bits of information available at ahdb.org.uk/IPM. So do check that out. That will be updated through the year with all relevant bits and pieces. We did touch on it, is the fungicide performance work that is available. It is discussed at the agronomist conference every year. There is a webinar recording which we'll talk about later, but it's all independent information looking at how all the fungicides perform in each season. So that is all available and is available on the website shown above. This year we are doing the fungicide, we've sponsored some entries into the ADAS Wheat Fungicide Margin Challenge. So it's the Wheat Fungicide Challenge. You can follow it on the website, but basically we have various entries competing to achieve the best wheat fungicide margin. Also, we've got work being put into practice. So work is ongoing at both of our all of our strategic farms. But equally, I've pulled out one of the articles where we were looking at lowering input. So that information is available on the website shown below. Publications and tools. Attached to this webinar is a copy of our cereal disease management guide that you can download. Equally, if you want to download it from the website or request a paper copy, you can do. We encourage everyone to benchmark, and that is an important part of cereal disease management, is understanding the cost of those fungicide inputs. So if you'd like to get involved with benchmarking, please do. You've got the Sphaerotinia infection risk alerts, which are available on our website at the moment, and also the arable research review that highlights all of the current research that's ongoing. As I mentioned, there are various webinars. You've got bits from Strategic Farm Week. We've got the Mollis Farm Monday on fungicide performance, and also you've got the fungicide performance work from Agronomist Conference. They're all available on the Cereals webinar archive. There are various knowledge exchange managers available across the whole country, so hopefully you'll know your local one, but if not, do get in touch with them if you have any queries, and equally everyone about is able to help. So that leaves me to say, when you leave this, you'll be taken to a survey. If you can fill it in, please do so. It helps us decide on what to going forwards in terms of webinars and bits and pieces, so do let us know your thoughts. This webinar has been recorded, so if you want to watch it back, you'll receive a link tomorrow. If you haven't already told us about basis and Noroso points, please do so, or follow up with an email afterwards. And if you've got any questions, there are some contact details for myself and the speakers below. Our next webinar, we're going back to the monthly webinars, so it's the first Wednesday night of the month. Next month, we'll be looking at crop nutrition and tissue testing. That leaves me just to say thank you to all of our speakers for joining us tonight. Thank you for you guys at home for joining. And also thank you to Christy in the background who's kept us on track. Have a lovely evening.